Today I'm going to demonstrate the experiment number 8 in your lab manuals. The title of this experiment is Testing of Power Cables According to British Standards. So it is a simple experiment that is used to measure the resistance and the diameter of different electrical cables. So as you know that in transmission as well as a distribution, to carry the electrical current, you need to have different power cables of different sizes, which depends upon your need. Of course, depend upon if it is a residential load or uh, commercial load. So how do we measure these different conductors, the sizes of them? So we have two basic standards that are used. One is British Standard Wire Gauge System and the another one is American Standard Wire Gauge System. The first one is prevalent in Pakistan and in industry, and the measurement of cables, the British Standard System is used. But let me tell you that AWG is more popular all around the world, and SWG is being phased out, and is being used only in Britain and some other colonies of Britain like Pakistan. So I will also link a video in the description on YouTube about the AWG system. That video is also very useful. That will tell you about American wire gauge system. But in this lab, I will focus on SWG system since it is used in Pakistan. So I will also recommend you guys to visit BASCC website for useful info. Let me show you that website. So this is BASCC website that tells you about different electrical tests that are to be performed on different electrical cables. Of course, there are so many number of tests. Number one is voltage test, which is only performed in high voltage laboratories. Only few of them are in Pakistan. One of them is in Comsat Aptabad, as far as I know. There is insulation resistance test. There are another tests that you can see on this website. It is a very useful website. I will recommend you guys to visit this site. Now coming to AWG and SWG conversion. So here is a basic chart that you can find easily on Google. Just type AWG to SWG, or also in some books of power distribution and transmission. You can easily find this chart at the back in the you know annexature or something like that in the end of the book. So as you can see, the 11th number in AWG corresponds to 13th number in SWG. So 11th number AWG is equal to 13th number in SWG. Both of the diameters are similar, almost similar. There is a little difference, like 2.30 millimeter. Here it is 2.34 millimeter. It does not affect much because here we are talking about currents of the magnitudes of amperes, not milliamperes. So 0.04 millimeter difference will not cause much difference. So here is a basic conversion of this one system to another. Now when it comes to SWG, it is further subclassified into two categories. There is an imperial category and the another one is in metric. So mostly you will see the description of an electrical conductor as number of strands slash diameter in inches multiplied by 0.001. Let me explain what it means. So a conductor of 7 slash 29, it means that there are 7 strands of wire in that particular conductor. Each of the wire is 0.029 inches in diameter. So here we have a strand of electrical cable. Sorry, we have an electrical cable. Inside there are so many strands, as you can see here. Look, there is a black cable. Inside there are so many strands. Red cable, there are so many strands. The color is not important here. So 7 slash 29 means that in this particular conductor there are 7 different strands. There are so many here. I'm not talking about this picture. Just imagine there is a wire, there is a cable, and there are 7 strands, and each of them is 0.029 inches in diameter. Why we write as 29 and not 0.029? It's just for simplicity. 29 is more easier to read than 0.029. So here that's why I wrote you have to multiply it by 0.001. Again, in metric system, you get the diameter of the wire as in millimeters. Just like here it was in inches, it is in millimeters square. So here it was only in inches. To get the square of it, of course you have to square it. You have to multiply it twice. So here it is millimeter square. Let me show you another chart. Here you can see this column shows the imperial sizes, this shows the metric sizes. Here you see 1 slash 0.044, it means one strand each of a 0.044 diameter, and likewise this one is the one that I quoted in the slides. And of course, when you find the area, nominal cross sectional area, you have to square it, square the diameter, divided it by 2, and multiply it by 3.14 pi. So I'm talking about the area of a cylinder, that area of a circle, or you can say a is equal to pi r square, because a cross section of any conductor or a wire is a circle. So it is basically a cylinder. When you take a cross section of a cylinder, you get a circle. So just it's simple formula pi r square. When converted in metric size, 7 slash 0.029 becomes 2.5 millimeter. So this is the cross sectional area in millimeter square. And again you can see here, this is the ampere rating. Okay, so on this website you can find the useful conversion. I will link this website as well in the description of the video. Now coming to finding the resistance of the conductor, there are two basic formulas. There is first one is A is equal to pi d square over 4, that I was talking about. So you just have to have a vernier caliper or a screw gauge. Screw gauge is more useful in this case, because screw gauge, as you must have performed the labs in applied physics in the start of your degree, the screw gauge or ECA1, I don't know, in whichever lab you performed it, screw gauge has a more higher resolution than vernier caliper. It measures 0.001 millimeter, and the vernier caliper measures 0.01 millimeter. So use screw gauge to find the diameter, and once you have found the diameter, you just have to put it in this formula, and then after putting in this formula you will get the area. And to find the resistance, we have this formula: rho divided by 2 multiplied by pi multiplied by yeah, multiply by pi multiply by length multiply by log d divided by d. Now what is d? D is this diameter that you used, and d, this one is the total diameter of the cable. So if there are 7 conductors, you can easily find this diameter, multiply by 7, and you will get the larger d. This will give you the capital R. So from these formulas, these are simple formulas, just you have to ponder over the formulas and you will get how to find these. And now there is another method to apply the DC voltage of 220 volt across a conductor and measure the resistance. Why 220 volt? Because here we are dealing with thick electrical cables. These are not simple electrical wires that you use in ECA1 or electronics lab. These are the thicker ones. So you have to apply 220 volt, and by using ammeter you can find the current easily, and using the Ohm's law, R is equal to V over I, you can easily find the resistance of electrical cable. Again, this video will help you in understanding AWG as well, the standard as well. It is a bit different than SWG.